So here are your notes, Unit 4.2, graphing quadratic. So 3 objectives: graph quadratics in vertex form, graph quadratics in intercept form, and also we're going to take those equations that are in intercept form and vertex form and learn how to transform them into standard form. So it's important to remember that the 3 forms that we went over in class are basically just different ways of looking at a quadratic. So if you have the same equation, you can start in standard form, transform it, the exact same equation, into vertex form, and then transform it into intercept form also, and the graph of all 3 of those would look exactly the same. So that's just moving them back and forth between forms, just like we do with linear forms, standard form linear, point slope, and slope intercept. So these are the steps that we went over in class that I would require for you guys to graph these. There's more ways than this, but this is the way that we kind of just went over in class. Okay. Standard form, vertex form, same thing. Find the vertex, extra point, find the symmetric point, and then sketch. Intercept form is the one's a little bit different. You're going to find your x-intercepts first, and then from there you're going to find your vertex, and you'll have your 3 points that I require, and then sketch your parabola. So vertex form, H and K. H and K give you your vertex. That's why I call it vertex form. You can look right at it and know what your vertex is without doing any work. It is important that you know that this minus sign right here means opposite. So whatever's inside of here, make sure you take the opposite for your H. For example, if you have x plus 5, then your H is actually a negative 5. If you have x minus a 7, then your H is actually a positive 7. Find an extra point. To find that extra point, you should be picking an x value around your H, just like we did with standard form. Plug it back in again after you get your x value, then get your y value, input, output, and you'll have a point. Use your axis of symmetry to find a symmetric point. At this time, you would have a vertex, an extra point, and a symmetric point. That's your 3 points to make your parabola. Then you draw your smooth curve. All right, so let's try this out. So the directions here say identify a vertex and axis of symmetry. So off to the side, I'm going to go ahead and put my vertex, which is a point, and my axis of symmetry, which is a line, and an axis of symmetry in our case, since these are functions, are going to be x equals. It's important to note too that since your vertex is in the middle of your parabola, it's actually on your axis of symmetry. So your axis of symmetry is actually going to be just the x value of your vertex. So if this was a 4, 5, then your axis of symmetry would be x equals 4 because that's the x part of your vertex. Those would match up all the time since your vertex is on the axis of symmetry and it's a vertical line. All right, so that being said, let's go ahead and find the vertex. So your vertex is h, k. So basically, you just take the 3 and the 4 and put it over here on your vertex. That's how easy this is. Now, it is important, like I said before, this is minus h, so you got to take the opposite. So right now, it's a positive 3. So your h over here is actually a negative 3. So I use a k, and like I just said, your axis of symmetry matches your x value, your vertex. So that's what was asked to be identified. We just identified it. So you're actually done with the second part of this. That was pretty simple. But now we got to graph it. So to graph it, we have our vertex. Now we got to find an extra point. So I'll draw a table just to help us out with this. Anytime you need to find points on a graph, you can always make a table. Input, output. So our vertex, when we inputted a negative 3, we got out of 4. So to find another point, we should pick a point that's around negative 3. So either a negative 2 or a positive 4. Sorry, negative 2 or a negative 4. I'll go ahead and go with negative 2. I think in our classes we chose negative 2. So we'll plug that in. So it's negative 1/2 times negative 2 plus a 3. You square that plus a 4. Negative 2 plus 3 is a 1. You square it, you get a 1. So 1/2 of 1 plus a 4. One thing here that I see a lot of students make a mistake about is they try to multiply in the 1/2 before they do the exponent. Just remember your order of operations. You should be doing parentheses first to get that 1 and then squaring it after. So negative 1/2 times 1 is a negative 1/2. Then you add 4 to that and you will get 3.5 or 3.5. So extra point, or we call it EP. Extra point is, let's see here, negative 2 and 3.5. Now in class we said that since -2 is the number right to the right of -3, then your symmetric point, since your extra point is basically symmetric with it, is going to be on the other side of your vertex, same distance. So symmetric point. Now you don't have to do this right away. You can do this after you graph, but I'm going to go ahead and do this right now. So if you go from -3 to -2 to go in the other direction, you go from -3 to -4. That would be on the other side of your vertex. And that should go up to 3.5 also, since this is symmetric. So what I'm saying is this. You have your vertex right here. You found out that your extra point is like down here. All I'm saying is that whatever distance it is from there, you're going to go this way, and now you have your graph. Yeah, looks like a top of a bald guy's head. So yeah, so that's your symmetric point. Now, like I said, if you have trouble kind of envisioning what I'm talking about with that, you can always just graph it. In your classes, I actually showed you guys how to do a not drawn to scale graph too. So not drawn to scale. So this is just gonna be a really rough sketch. I'm okay with this in the notes, but remember you should not be doing this in your homework. Notes is just to kind of save some time. So your vertex is at -3, -4. So -3 I know is to the left, so I'm just gonna put a little mark at -3 here. So remember this is just kind of eyeballing it. And then you're gonna go up to 4. Let's say 4 is about right here. So -3, 4. Put my point on. Next up is my axis of symmetry. Go right down there. All right, and there you go. That's your vertex and your axis of symmetry. Now my first extra point is at -2, 3.5. So -2, since this is not drawn to scale, I can just put that as long as it's on this side of it. So -2, 3.5, we'll say 3.5 is about right here. Remember, this is not drawn to scale, so it's about right there. Now, since I know that -2 is on this side of -3, the one that's going to be on this side that's the same distance will be a -4. So -4. And I also know since it's symmetric, that's going to go up to 3.5 also. That's what I was saying that I was doing in my head on the other side of the slide. So over here, you can kind of tell that if you know what an actual vertex is. And that's your graph. Okay. So let's go ahead and move on to, I don't want to make this recording too long, so let's go ahead and move on to the intercept form. Single page. Okay, graphing an intercept form. Intercept form means that you have your actual x-intercepts. So to do this one, first step is to find your x-intercepts. These are your p's and your q's. Now, since there's a minus sign here and a minus sign over here, you're supposed to take the opposite of both of these parts. Just like with the other form, it said a minus h, so we had to take the opposite of h. This one, you take the opposite of both the p and the q. Some teachers teach this as inside opposite is like a little way to help you remember that. If it's inside of parentheses with this, then it's going to be the opposite. So the x-coordinate is in the middle of P and Q. You're going to take the average. This is, or if I got to put it here, this is part of trying to find your vertex. Oh, right there. Never mind, I put it there. X-coordinate of the vertex is in the middle of P and Q. When you find the middle of something, you're taking the average of it. Well, you can actually take the mean also, but we'll say the average. Find the y-coordinate of the vertex by you're going to substitute whatever x-coordinate you get right here back in, and then draw your smooth curve. So let's go ahead and try that out. So with this one, identify the vertex, x-intercepts, and axis of symmetry. So your vertex, we'll go ahead and put the stuff that we're supposed to be finding over here. So V for vertex, x-intercepts. We know there's going to be 2 of them. Otherwise, it wouldn't be an intercept form. Axis of symmetry. Axis of symmetry is going to be x equals, and remember that's going to match up with your vertex. So this is the information that the question is asking. So this is what you're going to box. I just put it there first. That way we don't forget anything there. So this is your P. This is your Q. P is on the first part of the parentheses. Q is on the second part. One way you can tell it's in intercept form too is that you have it in factored form. You have the 2 parentheses around this, or 2 things being multiplied. So inside opposite, remember these are your intercepts. So you know that one x-intercept is at -2 because you got to change the sign. So it's going to be -2 comma 0. In order to be an x-intercept, your y value has to be a 0. So your q is a -4, so your second one's going to be a +4 because you change the sign. Hold on, gotta sneeze. Let me pause this so I don't sneeze into the... All right, that's better. So 4 comma 0. So we actually have 2 points right now. We have 1 point here, 1 point here. To find the x value of your vertex, since your vertex is the quote-unquote middle of your graph, or it's along the axis of symmetry, it should be right in the middle between these 2 points. So to find the middle of these 2 points, we should take the average of them. So we're going to average -2 with a +4. Another way to think about this, if you have a -2 and a +4, basically your intercepts are here and here, and you know that the x part, since your x, hold on here, since your vertex lays on the lies on the axis of symmetry, we know that the axis of symmetry goes down the middle of your x-intercept, so that's going to be the x value of your vertex. All right, so yeah, so just ignore this for now. So let's take the average. So average. So that will give you your x value of your vertex. So you're going to average that. So it's going to be a -2 plus a 4. Keep in mind you're averaging these 2 values, not your original 2 values. Okay. So -2, +4. You add them together and then divide by how many there are to find an average. So -2 plus 4 is a 2, divided by 2 is a 1. So the x value of your vertex is a 1. To find the y value of your vertex, you just plug it right back into the original equation. So it's going to be y equals -1 plus 2 and 1 minus 4. So that's going to be a -3 times -3, and that will be a +9. So 3 times -3 is a -3, and there's another negative. That double negative will make it a +9. So 1 comma 9. You automatically have your axis of symmetry. That's just your x value of your vertex. So axis of symmetry is a 1. From my little sketch right here, it kind of looks like that's about right. 1 looks like it's about in the middle, but that's, so I was going to say something and I forgot right when I was saying it. So let's move this over a little. So not drawn to scale again, just because I want to go faster through this. So x-intercepts at -2 and 4. So -2 is here, 4 is double that distance. Let's say it's about right there. So you got a point here and a point there. Next thing that we found was our vertex, which was at 1 comma 9. So let's say 1 is about right here. And then 9, +9, so we'll go way up here and say that's a +9. So this is where not drawing to scale kind of helps out, because then you just kind of, you don't got to make all those little marks. So it's coming down this way, draw your smooth curve. Smooth curve that way. Ooh, that wasn't smooth. Let's try that again. That's bothering me. Let's see how many times this takes me. See? Is that even in the middle? That's not in the middle. That's why it's throwing me off. Hold on, I'm going to fix this. Okay, I think that's a little better. Yeah, it's funny. I do not drawn to scale, and then I get picky about it not looking right. So, so if you don't draw something to scale, it's not going to look right. But yeah, so that's basically how it's going to look. We could already figure out that it's going upside down, because whenever you have a negative for your A part, it opens down. Positive would open up. So that's basically how you do the x-intercept part. So let's go ahead and move ahead to the transforming. So when you transform, you're basically performing all the orders of operations. If you notice here, you can square this binomial, add a k on, multiply by a, or multiply this out, and you should end up with the standard form, because standard form shouldn't have any parentheses on it. So you're performing all the operations. Similar to what we did before when we were simplifying expressions. So we're just simplifying this expression on the right-hand side. So let's try that out. So write the following quadratic in standard form, and now it's in vertex form. So order of operations says parentheses first. I can't combine these because they're not like terms, so I can't do the parentheses. Now keep in mind, parentheses does not mean multiply the 2 in. That's not the parentheses, that's multiplying. Multiplying comes later in the orders of operations. So since I can't do anything inside of the parentheses, next I go to exponents, which is a squared. Most common mistake I see people make here is they put x plus 5 squared, and they think you're supposed to distribute that in and get an x squared plus a 25. That is incorrect, so please do not do that. What you should be doing here is actually taking x plus 5, because when you square something, it means it's times itself. So if you actually wrote this out, it should say 2x plus 5 times another x plus 5 minus the 17. Now, we're eventually going to learn some ways of multiplying these, but we haven't made it to that section yet. So for now, just think of a squared as separating them into these two. Now you want to multiply these, so you're going to take the x and distribute it into the x plus 5, and take the 5 and distribute it into the x plus 5. So you should end up with a 2 times, so this is still in parentheses, x squared plus a 5x plus a 5x plus a 25 minus 17. The way we did that was, remember I showed you guys that you're supposed to distribute two parts here. So you can take the x and distribute it to the x plus 5. So x times x is x squared, x times 5 is 5. Then you take the second part and distribute that also. So 5 times x is this 5x, 5 times 5 is this 25. Some of you in the past, you might have multiplied it with using a box. I'm okay with that. So you have x and 5, x squared, 5x, 5x, and 25. So if your teacher taught you like that in the past, I'm fine with that too. But this is still 2. And remember, because you're still multiplying by 2 to whatever you get as a result here. So you still got to multiply all this stuff by the 2. So this will be x squared plus a 10x when we combine like terms, plus a 25 minus a 17. Now I can distribute the 2, so it'll be a 2x squared plus a 20x plus a 50. It's out of parentheses now, so I can subtract the 17 from it. That'll be a 2x squared plus a 20x plus, see here, 33. Yeah, 33, positive 33. So y equals that. That is now in standard form. A is 2, B is 20, C is 33. So that's how you turn it into standard form. You just multiply it all out. We'll go and do this one too. This is in intercept form. In the past, I've had students kind of confused about what this actually means. If you think of this as a -3 times a group of stuff times another group of stuff, that's the way that you're supposed to actually be looking at this. So if you had like a 3 times a 4 times a 5, you would multiply these, or you don't have to multiply that way, but you can do 4 times a 5, but whatever that entire thing becomes, which is a 20, you still got to multiply that whole thing by a 3. So in our case, we're leaving it inside of parentheses like that. So I guess a more accurate example would look like this. If you had 3 times 4 times 5, basically you do 3, 4 times 5 is a 20, and you can leave it in the parentheses still because you're still multiplying it into the 20. That's why we left it in parentheses even after we multiplied it all out, because you still have this 3 being multiplied to everything. Now, same thing though, you could actually take the 3 and multiply it to the 4. So here, this is considered one thing. You could actually take the 3 and multiply it into the x minus 2, keep it in parentheses, and then multiply it to this. You'll get the same answer either way. I'll go ahead and show that too. So I'll do this 2 ways. So the first way, I'm going to multiply the parentheses first. If I multiply the parentheses first, I'll get a -3. X times x is an x squared. X times 8 is an 8x. So that was the first distribution of this x. Second distribution is a -2, so I'm going to do -2 times x is a -2x. -2 times 8 is a -16. That'll be a -3 times x squared combine like terms, you get a plus 6x minus a 16. So now I can distribute the negative 3, and we'll get a negative 3x squared minus 18x. 3 times negative, that's a positive. 6 times 3 is 18. Carry your 1, 3, 48. So y equals that. That's now standard form. That's if you multiplied the parentheses first. Now let's see what it would look like if I actually distributed first to this x minus 2 with this 3. So if I distributed first, it would say negative 3x plus a 6. So all I did is I just took this and multiplied it to this first parentheses. I don't multiply the 3 to both parentheses. That'd be like doing this and do 3 times 4 and the 3 times a 5, which is not how this works. You multiply the 3 times a 4, take that, and then multiply that by that 5. So same thing here. I multiplied in the negative 3 times x, got the negative 3x. Negative 3 times negative 2 is positive 6. Now I'm going to take that and multiply it by the x plus 8. And I should get the same thing. So double distribution here, binomial times binomial. Negative 3x times x is a negative 3x squared. And negative 3x plus 8 is a negative 24x. Okay, so I just did this distribution. Now I'm going to distribute the positive 6. 6 times x is a positive 6x. 6 times 8 is a 48. All right, so putting all that together, it'll be y equals negative 3x squared minus an 18x plus a 48. And yep, that matches the other side. So my only point here was you can do this either way. Kind of lengthy point, but since it's multiplication, multiplication is what's called commutative, so you can do it in any order you want to, and it's not going to mess anything up. You could even do the negative 3 times x plus 8 first, and then multiply by that x minus 2, and you'll get the same answer. So that's how you do the homework. So get it done, and then I'll check it tomorrow. Okay, bye-bye.